Good afternoon or good evening to all our dear Prestige customers. Thank you very much for waiting. A very warm welcome again to Harding Web Seminar, Shaping the Connectivity of the Future for Energy Storage and Data Center. Today, our expert from Singapore, Australia, and Germany will present us about Harding Company and how Harding plug and play connectivity solutions save cost and improve efficiency. Let me hand over the time to our first speaker, Mr. Alvin Lee, Sales Director of Harding SCA. Alvin, over to you.
Thank you, Ada. Hello, everyone. Thanks for taking the time to join our webinar on data center and energy storage system. I'm Alvin, and I'm the Sales Director for Harding Singapore. So I've been with Harding for 15 years, and I'm responsible for the Southeast Asia region. On the slide here, you can see the context of the team who is responsible for the various countries in Southeast Asia. We have Edwin Tay here, who just recently joined us this month, and he's stationed in Singapore. And next we have Chi Hao, who is stationed in Penang, Malaysia, and Chawit in Bangkok, Thailand. Both of them have been with Harding for 2 years now. So if you have any queries, please feel free to contact us. Next, I'll hand over to my counterpart from Australia, Mr. Robert Heddick.
Thank you, Alvin, and g'day everyone from Harding, Australia. Thank you for taking the time to join us on this webinar. My name's Rob Haddock. I'm the business manager for Harding, Australia. Very similar to Alvin, I've been with Harding now for 15 years. Also, just like to introduce the Harding team in Australia. So we have Matthew, our senior field sales engineer, and Matthew's been with Harding for about 10 years, and he is based out of Sydney. The newest addition to our team is Nick. Nick is based in Melbourne and has been with us just over the 12 months. So if there's any inquiries or any further information that you require, please feel free to contact one of us, and we will attend to your needs as quick as possible. So thank you and welcome everyone.
Thank you, Robert. In the following time, our key presenter from our headquarters in Germany, Mr. Andres Misraj, our Global Industry Segment Manager of Data Center and Energy Market, will tell us more about how Harding connectivity can speed up scaling and deployment in the data center, and how connector selection can improve energy efficiency. Before I hand over to Andres, I would like to encourage our participants, all of you, to use the chat box to raise questions. After all the presentation, there will be Q&A session when our expert love to hear from you and answer your questions. So as you see in the slide at the bottom of the Zoom, there is a control bar where you can see the chat button. You can click the chat button to open the chat window and type your questions there. It will be either on your right side or in a chat window if you are using full screen. I hope you will enjoy our web seminar. Do interact with us. Keep our presenter busy. I'm sure they like challenging questions. Let's welcome Andres.
Once again, thank you so much. I will just start the presentation about the topics, which just my colleagues were so kind to introduce. Now, the first part of my short presentation will be about the data centers. And there I will show how the Harding connectivity solutions can help to save energy. And the second part of my presentation will be about the energy storage systems, which are really well connected to this data center environment as well, and what kind of future-proof solutions we can have also to provide safe power to the energy storage systems. So what we can see now is how the electricity usage in the world will be growing dramatically in the next couple of years. So the basis which we see on this slide is 2015, and then we see two different scenarios for 2030, and in the expected scenario we can see with the green color how much energy will the data centers globally use from the whole electricity supply. And it's really surprising. Even today, it's more than 1% of the electricity usage, which the data centers are taking from the whole. But that time, at 2030, it is expected to be even at 6% level. So huge electricity demand by the data centers all over the world. When we go inside the data center operation, then we can see between the different operational costs or categories of the different operational costs that the electricity usage itself in the data center is more than 50% of the running expenses of such a facility. So of course, based on this, the data center operators and the designers of data centers are really keen to reduce the electricity usage of a data center or optimize actually the power usage. One of the most important KPI, performance index, that in that regard for the data centers is the so-called power usage efficiency. You can see on the right side of the screen that if this number, this PUE number is high, it means that the data center electricity usage is not efficient. And as much as this number is going down, this will be the better outcome of the efficiency. So from the last decade, I would say, or 15 years, it was a very nice process from the data centers to reduce this number. And you can see on the graph that by 2014, 16, it was really a big effort and successful effort to reduce the power consumption of the data centers. But somehow, since that time until today, we are kind of on a flat curve. We cannot bring it down. The reason for that is that all the big systems in a data center, such like cooling systems and other big elements, were already affected, optimized. And what can be done right now? This is the next question. But before we answer that question, we can look into a schematic of a data center facility. And I would like to point out how the power is flowing in such an environment. So of course you are coming from the grid side, and then you have high voltage or medium voltage feed in to the data center. Then you have the switch gears, the different transformers, of course, and then we go to the low voltage level. So when we are at the level of low voltage, there is a lot of electricity used by, for example, the lighting and the mentioned cooling. But then we go through some UPS devices to, uninterruptible power for the data center, and we go into the IT space, where basically the system suppliers, so many of our customers, are playing a role. And already on this slide, you can see some areas where the connectors and the connectivity is playing a very crucial role to feed the servers actually, and to have the power from the facility to the so-called PDUs or RPDUs, so the power distribution units. Different philosophies, we can see here how this is done in the reality, what kind of design is there. Just point out some of the different examples, but all you need there is a reliable power supply. And then we go to some application examples from Harting. So we've been working very hard in the previous years to supply our customers with a solution which is really actually failure proof, because this is all critical power in the data center. And the solutions, what we saw in data center environments, using some plugs, some commercial plugs, it was really clear that those solutions probably not the best for a critical power environment. So one of the places is in the server room where you are distributing the power, and it's many places. In many places, they use the overhead bus bars or busways, and you can already see one example here with Harting connectors, where you can plug in the cables and feed the server racks with the power. The other example is connecting to the previous one, but it can be also standalone. So in some cases in the data centers, you have all the cablings under the floor or in the server room. So there you also have to come from a power distribution cabinet to the servers. And what we see on this slide on both of the pictures is how a Harting connector nicely fitting on a power distribution unit. So it can be done from the top of the PDUs, it can be done from the side of the PDUs, but what is very important is the footprint, is also the rigidness of the whole system. So some pictures about that, of course, I was happy to share with you. When we go to the product offerings, you can see here on this slide that we have pretty much a nice portfolio in this area for the data centers, which we built up actually in very close relation and work with our big and smaller customers. So at the one side, actually downside of the picture, you see the Han Q connectors. They have smaller footprint and also smaller amperes. And then the others, what you see is basically the Han Eco series, which is very successful in the data center market for Harting. What I would like to point out is that all in these connectors, you can use the so-called inserts, and they are modular. So in some of the pictures, it can be seen already here that some small modules are coming into the hoods and the housings inside to this connector. So that means there are a huge variety of solutions which can be designed from these inserts. A lot of varieties also for power, signal, and data. And the Han modular series is rated up to 600 volts for the power, AC power, and 250 volts for the signal service. So it is really a nice way to have a lot of different options with the modular systems. On this screen, you can see what can be done out of just, let me say, just supplying the best connector for the data center. We can go further. We have specific solutions, Harting-specific solutions, where the customer is telling us what would be the need in way of cables or even some distribution boxes or cabinets, and Harting is ready to provide the whole solution to the customers, shipped on their site, pre-tested, and it's really a plug-and-play solution. Very convenient for the customers, especially for those who are having data centers worldwide. We can think about the big hyperscale data center providers. We know them very well. We use their programs as well every day. So they will have facilities all over the world, and it's very convenient and very important to ship ready and customize plug-and-play solutions for them. In this overview of the benefits for our customers, I would like to take your interest on the right side first. So the red colored connector or plug actually is the one, the IC plug, which I was just mentioning. You meet them a lot still today on data center environments. this is really a commercial way to do something with the power. And on the left side, comparing to that one, is a very sophisticated industrial level connector, an eco connector from Harting. So the benefit is, of course, one of them is the shape and the size. So they are quite smaller. The modularity, this is the best thing for our customers. And yeah, the termination technologies can vary as well. We can have direct connection to PCBs even. And yeah, it can be interchangeable between male and female contacts. So pretty much all benefit for our customers. But how do we come to the topic of energy saving? We say that modular, we say that it's plug and play, but how this even can be connected to energy saving? So we did a test in an independent laboratory comparing the two solutions, which you just saw on the previous screen. So one is the Han Eco from Harting, and two different manufacturers' product from the CE connector or CE plug level. And when we took the measurements, actually we measured the loss, the power loss on the connector itself. So due to the voltage drop. And once we measured this and made our calculations, we also considered, of course, the price of electricity for the data center user. And we took 15,000 rack data center as an example with 63 amp connectors. So just to actually compare apple to apple. And where we came to is that it's up to 50% save in annual power consumption on the connector itself. So pointed out, this is the power which is flowing through the connector. 50% less energy is lost when you use Harting. Of course, it's a nice number, but what can this mean really to the operational side of the data center, so the costs? So taking the mentioned electricity prices and costs, we came to up to 100,000 euros save yearly for such a data center. So this is where I come back to what can be done after the big systems are optimized in the data center. The clear answer from our side is to even go to the smallest systems, and look, with a connector, you can save 100,000 euro every year with cost and of course with usage of electricity. So this would be the part which I wanted to show you about the data centers and how Harting is coming into the scope and how Harting is helping the customers. So I would like to invite my colleagues with me in this online session to probably have questions or to have some discussion between each other, first of all.
Thanks, Andres. Rob here from Australia. Those savings that you mentioned there, they look quite significant and quite impressive. I'm just wondering, when you said that they were calculated on electricity costs, were those costs, because over the last year or so, electricity costs have really exploded and increased so much. I'm just wondering, when were your calculations done? Were they done on the current today's electricity costs or a couple of years ago?
Yeah, thank you. Actually, this is really interesting. So this example which you see on the screen, it was still based on the time of the actual testing of the connectors, and that was roughly 2 years ago. So I would say I wanted to show this figure 100,000 level of euros to be absolutely on the safe side. But as you just pointed it out, it's much more saving in the reality today for our customers. I calculated recently what would be the figure, and it's even plus 70,000 euros. So yeah, almost double So as much as the electricity cost is going to the skies, as much this saving is higher, of course, for our customers.
Thanks.
Yeah, thank you.
Okay, Andres, as Alvin here. So I have some questions as well. Earlier, you showed those cable assembly and distribution box, and they definitely look very nice. You mentioned about this HCS. Maybe can you tell us more about what is this HCS and what does it really do in manufacturing or in designs? Anything you can tell us more?
Of course. So Harting has global business units, and one of this global business unit is called HCS. This is the name is actually Harting Customized Solutions, and this is one of the best growing parts in every way for Harting, for new customers, also for year on year percentage of growth. The reason is that more and more customers and partners, I can already call them, are requiring special solutions. So we start with them from the design, as you just pointed out. We sit together with them and we design a product together with them. This is the highest success factor, and it's really showing in the figures and in the reality, because this is needed and this is where we can support our partners. So be there with the design, point out what would be the best connectivity solution. We have roughly 30,000 part numbers today, so this is really a good way to support our partners, as I said. So customized solution, and this is the high runner at the moment, and I expect this will be also in the future, so even more so.
Thank you, Andres. Yeah, I'm sure we'll receive more inquiries from our customer now for our HCS business. Okay, looking at the time, I think we shall proceed to the next topic on energy storage system. And just a reminder again, if you guys have any questions, please feel free to send your question to the chat box. And over to you again, Andres.
Yeah, thank you so much. Nice discussion. And I would like to, as you mentioned, go to the second topic of today's web seminar. This is about the energy storage. So the energy storage is playing also a crucial role in many places in the grid, but also in the customer's place. So in the data center environment as well. So really pointed out several times that the crucial power, so it has to be there always in the data centers as well. And if there is any failure in the network, if there is any failure in the grid, and the electricity stops flowing in, then there is a huge problem. We just saw recently in the news what happened in some of the big operators places where there was a blackout of power, for example, and that costs millions, even billions of dollars for the business and also for the operator. So energy storage is really one way to solve this issue, because we can save the energy on the site. We can always have a huge backup in this system. So that's why I wanted to show energy storage as well. But before, let me drink something. So what you can see here is an overview of the energy storage application areas. And of course, when we think about energy storage, what we do is just think about the picture which I just showed you, or some cabinets, or something at home which we have as a battery backup for the solar panels, but it's really something bigger even today. So one part is the electrical grid part, where energy storage is playing a crucial role, and it will be in the future as well, even more. For example, if you need large capacities to store. It's some slower discharge and slower charging. That is called seasonal storage. It's on the left side with the blue color. And there you can use, for example, hydropower to do this, or hydrogen storage, which is also a hot topic recently. But in the grid as well, of course, we need for some solar parks or wind parks, something where we can have the hours of supply. So for some hours to store the electricity, that would be another kind of application areas. For example, compressed air or thermal storage. And here comes the battery. The batteries here are where they are coming into scope. When we look in the commercial or industrial usage, I am sure the biggest topic now and in the future in the so-called energy storing or storage is the electric vehicles, because the electric vehicles batteries will be so huge altogether that they will be the biggest part of this market in the coming years, and of course in the future probably. So here you need high power and a very durable solution. Here you can use hydrogen or fuel cells, but of course, as I mentioned, lithium-ion batteries. So just to have an overview that energy storage is about a lot of different applications. And for me, it was really surprising still that 90% of today's energy storage is gone through the hydro energy. So basically what they do is that they have a water level somewhere higher, and then they have a water level somewhere lower, and they drop the water from high to the low and use the generators to provide the power. But this can be taken back to up and stored as an energy source. And this is 90% of today's application. But the rest of the applications are also very interesting. For example, the electromechanical part, which I just mentioned about the batteries. When we go to the batteries, the lithium-ion batteries are actually covering today 92% of the battery storage systems. In the next applications, I would like to show you interesting solutions from the battery area. This is where Harting at the moment really can help you with many different connectivity ideas and solutions. One of the philosophies to connect the battery cells and battery packs actually to each other in a cabinet or even in a big container is from the front side of the batteries. So you can see on the pictures from left and right side, both front side connectivity. In this case, the connectors can bring already big benefits. Previously, I saw a lot of hardwiring solutions, but really it is true that doing hardwiring on this level, electricity level, is very dangerous. It's a safety issue. So where we really pointed our focus is to have safe connectivity. This, for example, we can do through finger protected connections. We have visual locking systems. So the operators or the mechanical engineers and colleagues on site can always see if there is a connection closed or opened. And it's also providing you a very fast way to change modules if there is any failure. The other solution, the other philosophy, which you can see with battery energy storage systems, is that the connection is done at the backside. Of course, this benefits or actually the positive effects using this is a bit different than the front connectivity. The most important would be for me is that using blind mating and docking solutions, you can combine power, signal, and data together. So when we saw the front connectivity just one slide before, it was a power connector only. Here you can combine many of them. And it's even more safer in the way that there is no reach for the live components, no way from the front side. If you open the cabinet, you cannot touch anything which is live. And again, it is also a nice solution to fast change any failure or failed battery module. For the front side connectivity, which I mentioned, is the best solution from us, our HAN-S series, which has many nice aspects. Of course, we can go to 1,500 volts. We have mechanical coding, which I just mentioned, so there is no failure of changing the plus and the minus. We have finger protection, and the termination itself for the on the batteries can be as well various, and the rated current is 200 amps. This is the overview of the HCS solution, which already Alvin was pointing out. So the customized solution from Harting. Of course, for this application area, we also have new designs. On the left side, you can see the HAN-S connector with the cable assembly. And on the right side, you can see an energy storage system connected with the docking frames, but also pre-wired, pre-tested, and so on. So shipped to the customer in a ready solution. Summing up the connectivity, and I think this is really the future, and that's why we call it future for this area as well, is to provide something which is error-free on the site. Bringing up huge energy storage systems, but it's also true for the data centers, which we were talking about. As fast as possible, it costs as less, and the customers can get online as fast. So the installation is safe with the visual locking and the finger protection. And we have a very interesting and nice feature, which you can see here. So our HAN-S connector is actually rotating, which means if you connect the batteries together with the length of the cable, you can play with this connection, and it's very handy on the site. It's very fast, and you can a little bit turn here and there. So align to the best way to plug the cables to the batteries. And yeah, the last one probably to point out is the UL certificate for our international and huge customers. It is very important to have all the necessary certificates. So that would be the last slide from my side to this energy storage topic. And probably we can also have some words together with the colleagues.
Yeah, Andres, thank you for that. Rob here in Australia. Just back on the Harting customized solution. So the HAN-S, with the cable assemblies, do they come in predetermined lengths, standard sort of off-the-shelf lengths? And can we also, if a customer requires a little bit more customization, whether it's on the length or different connectors on the other end, can we provide that?
Yeah, of course, absolutely true. See, in this application area, usually the length of the cable is pre-designed, so it's already decided in advance. So we have a lot of cable assemblies which are off the shelf. So it means same size in big volumes, but of course it is very easy for us in our manufacturing HCS facilities to to change anytime. So we know that the design can change very quickly, or we know there are special projects sometimes for our customers, and we can quickly react and change the length of the cable as it is needed. So it's absolutely not a problem.
Cool, thanks.
Okay, Andrews. So I see that you one of the slides show that the HAN-S current rating is 200 ampere. Is this the only one we have, and why is this so? Is it because it's the only common one that is used in the market? Will we have other variants with other current rating?
Yeah, correct. This is mostly the level of amperage which is used on the market today. So we were really targeting big share on the market with this solution. But as I mentioned to you, this is a series. So this is a portfolio which we are bringing every time with new products on the market. So the 120 amps version, which is a little bit smaller one, which is also very much needed recently, will be coming soon. And we are also looking at the other side of the aspect where higher amperes are needed, for example, in shipbuilding. So big ships, they use higher amperes. And this is where we are also having designs in the future to be coming as a product.
Oh, okay. Thank you.
Welcome.
Okay, thank you, colleagues. So let's see what question that we received in the chat box. I see several questions there already. So let's start with the easy one. So one of our customers asked, what are the general benefits of the Harting docking frame? Can Robert take that?
Yeah, thanks, Ada. Always happy to take the easy questions. So the general benefits of the docking frame is, as you saw, modularity. So being able to combine power, data, signal, all in the one solution, in the one connector. That's a very popular requirement from customers. So you cover everything, whether it's high power, low power, data, communications, or even just low power signals. But probably what brings the docking frame an extra benefit is its blind mating compatibility. So it can basically, you'll have one side of the frame that is fixed, the other side is floating, which allows for self-alignment, which is quite critical in blind mating applications. So drawer applications or rear mounting onto a rack, onto like a backplane. So being able to feel confident and have a guaranteed self-aligned mate is definitely one of the better features. Also the variety. So you can get it, the docking frame in a 2-module solution, 3 modules, 4 and 6 modules. So literally there are 50 million possible combinations of the different modules and the different sizes. So just summing up, the key benefits are self-aligning, so blind mating is guaranteed, and having the ability to do power, data and signal in the one connector.
Wow, impressive. Thank you, Robert. So let me see. There is another product-related question. One of our customers asked, what are the major differences between Han Eco and the conventional Han modular series? So can Alvin answer this?
Okay, sure. I can take this. So I think on the major differences, well, I think the most obvious you can see that is the material of the Han Eco and the conventional modular system. For customers that are familiar with our conventional Han connectors, I'm sure you know that the modular series use our Han A or Han B hook, which are usually made of metal. But in this case, the Han Eco is used plastic, or actually it's a very high performance plastic, which is a polyamide. And though it's plastic, but definitely it still give you the high degree of protection from the shock and vibration, and is IP65 and is UV resistant. And with the plastic material is actually lighter in weight and more cost effective. Another important difference is that using a Han Eco, you do not need an additional hinge frame as what is compared when you use a conventional Han modular series with the metal hood and housing. So without the hinge frame, removing this hinge frame, it will allow for one additional modules to be used in the same footprint. Okay, just give an example. If you are using a Han Eco 6B, you can now use 3 modules instead of just 2 modules if you use a Han modular 6B. So in fact, so now if you can use 3 modules with the same space and size, you can have a higher density, or you can add more power or data to whatever you want, basically. Yeah. That would be the main differences.
Very nice. So it's lighter in weight and more cost effective. Okay, let me see. So probably we can answer one more questions. And let me see, there will be a more difficult one for our headquarter expert. Okay, let me pick this one. All right, so one of our customer asked, in the data center world, they have heard about the term RIP cable for power distribution cabinet, PDC. So what are these? It goes to Andres, please.
Yeah, thank you so much. Of course, my pleasure as Robert for the easy, for me, pleasure for the hard question. WIP cable is actually a cable assembly. So this is very familiar to those which you saw one of my slide for the HCS solution for data centers. So WIP cable is at the one side a male cable assembly, so the male connector from Harting, and usually still the IEC, the red connector on the other side. And the Harting side is as I mentioned, the male connector. So the power distribution cabinet has a lot of outgoing WIP cables, and this cable will go directly to the power distribution unit. You know, the ones which you saw also on the slides, they are actually mainly on the part of the rack cabinet, so side of the rack cabinet. And this WIP cable is feeding the power, the main power, to these PDUs. Probably it makes sense to mention one more thing here. The power distribution units, PDUs, are this high long distribution devices in the sides of the different rack cabinets. But there is another way how to bring power to the servers, which is this vertical way, and those are the units which we call power shelves. I'm just mentioning because I'm sure our viewers are coming to those terms as well. It's a little bit different with a little bit different connectivity, but of course, the power shelf connectors we are also supplying to one of our biggest customers. But back to the WIP cable, it's basically a male cable assembly feeding the power to the RPDUs.
Thank you, Andres, for the nice answer. So because of the time constraint, for those questions that we are not able to answer right now, we will be sending the email reply to you. So here comes to the end of our web seminar session. Thank you, Andres, Alvin, Robert, and thank you everyone for attending today's web seminar, Shaping the Connectivity of the Future for Energy Storage and Data Center. You are very welcome to contact our SEA ANSAC team for further questions or queries. Our sales team will be very happy to receive your feedback. Actually, Harting will be hosting another web seminar topic, authorization, and digital service on December 6th. We look forward to your participation again. We say goodbye for now, and we wish you have a good rest of your day. Hope to see you next time. Goodbye.
Thanks.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.